Okay, Algebra 2, today we're going to graph rational functions. Last time we graphed rational or reciprocal functions where the numerator was just a number. Now our parent function, or I don't know if it's a parent function, but the function, a rational function is going to be of the form, let's get a different color, f of x equals p of x over q of x, where p and q are both polynomials and q is not equal to 0. Okay, and here are going to be the steps you are going to use. You're first going to simplify the function. Then you're going to find the x-intercept and the y-intercept. Nope, we're going to just find the x-intercept. Okay. We're going to find the x-intercept by setting the numerator equal to 0, which is p of x. And then we're going to find the vertical asymptote by setting the denominator, which is q of x, equal to 0. And then we're going to find horizontal, that's the vertical asymptote. Then we're going to find horizontal asymptotes using these rules. Okay, there's a little chart right here, and it's going to be degree of p and degree of q. Okay, degree is the biggest exponent of x. And then this over here is going to be our horizontal asymptote. So if the degree of p is greater than the degree of q, then there is none. No horizontal asymptote. If the degree of p is less than the degree of q, then the horizontal asymptote is the x-axis or y equals 0. Same thing. And if they are the same, if the degrees are the same, then the horizontal asymptote is going to be y equals leading coefficient of p divided by leading coefficient of q. That's going to make way more sense once we look at some examples. Let me give you just a couple little examples of this. Okay, p is greater than q. That means it would be something like x squared plus 3 over x minus 1. Okay, if that was our function, the degree of the numerator is 2, and the degree of the denominator is 1, because the exponent of x is 1. P is greater than q, so there's no horizontal asymptote. That's what we're looking for here. Okay, where p is less than q, an example might be the opposite of that. What if we had x plus 1 over x squared plus 3? Okay, the degree of the numerator is 1, the degree of the denominator is 2, so p is less than q. So that tells us that our horizontal asymptote would be the x-axis. And if they were the same, we could have something like this. The degree of the top is 1, the degree of the bottom is 1, they're the same. So our horizontal asymptote would be the leading coefficient of the numerator. That means the number that is in front of the highest exponent of x. So that would be a 1, and the leading coefficient of the denominator would be a 1. So our horizontal asymptote would be y equals 1. If they were different, let's try, well, let me do a different one. I'll just do the same. If we had this instead, 2x plus 1 over x plus 3, then our leading coefficient of the numerator is 2. The leading coefficient of the denominator is still 1. So our horizontal asymptote would be y equals 2. Okay, I think it will make more sense once we do some examples. But we also have to deal with holes. The last step in graphing these is identifying any holes. Okay, that's our last step, step number 5. A hole is a point, x, y, in which there is a break in the graph. A hole occurs when there is a common factor between the numerator and the denominator. Okay, and there it tells you right there, to find the x, you set the common factor equal to 0, and then you take that x and put it back in, and you get the y value. Okay, we're going to do examples, and it's going to make way more sense. So let's just start with a simpler one, and we'll get to the holes in a minute. Okay, number 1, x minus 4 over x plus 4. So let's do all the steps. Step 1, simplify the function. Is there anything we can do to simplify this function? No, it's already as simple as it can be. Step 2, find the x-intercepts by setting the numerator equal to 0. So we're going to take the top, set it equal to 0, and we get x equals 4. The x-intercept is a point, 4, 0. Okay, the next step is find the vertical asymptote by setting the denominator equal to 0. We're going to take the bottom, set it equal to 0, and we get x equals -4. There's our vertical asymptote. Here's our x-intercept. Then we're going to find the horizontal asymptotes by that little chart. Okay, what is the degree of the numerator? 1. What? Because the exponent of that x is 1. What is the degree of the denominator? 1, because the exponent is 1. So the degree of p equals the degree of q. So the horizontal asymptote is y equals leading coefficient of the numerator, which is this one, over leading coefficient of the denominator, which is that one. So it's y equals 1 is the horizontal asymptote. So you've got all of those things off to the side there. You've got x-intercept, vertical asymptote, horizontal asymptote. Then you've got hole. There's none for this one. And you've got domain and range. And domain and range is same as before. Domain goes with vertical asymptote, so x not equal to -4. And the range goes with the horizontal, y not equal to 1. And we can go ahead and graph it. Okay, start with the asymptotes. X equals -4, 1, 2, 3, 4. And horizontal, y equals 1. So it looks like that. Now all we need to know is, will the graph be here and here, or, oh man, or will the graph be here and here? So let's see what we know. We know the x-intercept is 4, 0. So let's put that in. 1, oh my goodness, I'm having a lot of trouble with my x-axis. All right, 4, 0. 1, 2, 3, 4, 0 goes here. So you know that that it's going to look like something like this and something like this. And at this point, you can just put those in. If you would like to make a little chart and find some points, you can. I'm not really that concerned about it. I want you to find the asymptotes. I want you to find the x-intercept, and I want you to find holes if there are any. All right, let's look at number 2. F of x equals 2x minus 6 over x minus 1. Okay, the first thing it says is to simplify. Can we simplify? Well, we actually can. We can take a 2 out of here. But in doing that, it doesn't help us. We can't simplify it any more than that. So it doesn't really matter if you leave it like this or if you leave it like this. You can do either one. So let's do the x-intercept by setting the numerator equal to 0. So I'm going to set this equal to 0, and I get x equals 3. So my x-intercept is 3, 0. Remember that your intercept is a point. It isn't just a number, it's a point. Then our vertical asymptote, we're going to take the denominator and set it equal to 0, and we get x equals 1. There's our vertical asymptote. Our vertical asymptote is always of the form x equals something. Then we have our horizontal asymptote. We got to look at the degrees. What's the degree of the numerator? 1. What's the degree of the denominator? 1. So they're the same. So the horizontal asymptote is going to be y equals the leading coefficient of the numerator, which is 2, and the leading coefficient of the denominator, which is 1, because there's a 1 in front of that x. So it is y equals 2 is the horizontal asymptote. The next thing are holes. There's none. We haven't gotten to those yet. And we got our domain and our range. Our domain goes with our vertical, and our range goes with our horizontal. Let's go ahead and graph this. And we have x equals 1, y equals 2, and we have a point of 3, 0, 1, 2, 3, 0. So we know that it's going to look something like this. So that means our other part has to go there. And that's the answer to number 2. Okay, let's look at number 3. Now we're going to get into our holes. F of x equal, well, yeah. F of x equals x squared minus 1 over x minus 1. First step, we simplify. So we're going to factor the top and the bottom. And look at this. We can cross that off. So we can rewrite our function just as f of x equals x plus 1. Okay? X-intercept. How do you find the x-intercept? You take the numerator and you set it equal to 0, and you get x equals -1. And then we're going to find the vertical asymptote. You're going to set the denominator equal to 0. The denominator is just 1. Can 1 ever equal 0? No. So there is no vertical asymptote. Then we're going to look at the horizontal. What's the degree of the numerator? 1. What's the degree of the denominator? 0, because we could think of it as x to the 0 power. So the top is bigger than the bottom, so there is no horizontal asymptote. Now we're going to get into a hole. When you cross off something like this, that's where you get your hole. So you're going to take the thing that you crossed off, which was x minus 1, and you're going to set that equal to 0, and you're going to get x equals 1. That is the x coordinate of the hole. Then you're going to take this and you're going to put it back into our simplified version. Remember that our simplified version now is just f of x equals x plus 1. After we crossed this off, so we're going to substitute 1 in for x, and we're going to get y equals 1 plus 1, or 2. So our whole is a point of 1, 2. And now our domain and our range have to go, remember our domain goes with vertical asymptote, which is none, but it also goes with the x-coordinate of the whole. So x doesn't equal 1, and range goes with the horizontal, which is none, but it also goes with the y-coordinate. So y not equal to 2. So let's graph this and see what it looks like. How are we going to graph this? What is this? What is this? It is a line. We simplified it to a line. So you can just go ahead and graph that line however you want, however you like to graph lines, except there's a hole at 1, 2. There's a hole right there. So we have to put a hole. And we also know that -1, 0 is in there. If we wanted to graph it with the y-intercept is 1, and the slope is 1, 1, 1, 1, 1. So this is what our graph looks like. It's a line with a hole at the point 1, 2. All right, let's look at number 4. Number 4, we've got f of x equals x plus 5 over x squared plus 9x plus 20. First thing we have to do is simplify. What multiplies to give you 20 and adds to give you 9, 4, and 5. And now you can see that we can cross off the x plus 5. So our function becomes 1 over x plus 4. We simplified it down to that. Now we're going to find all our parts. X-intercept. You set the numerator equal to 0. The numerator is 1. Does that ever equal 0? No. So there is no x-intercept. Means it never crosses the x-axis. Vertical asymptote. You set the denominator equal to 0. X plus 4 equals 0. X equals -4. There's our vertical. Horizontal asymptote. You look at the degree. What's the degree of the numerator? 0. What's the degree of the denominator? 1. When the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0 or the x-axis. Whole. You take what you crossed off. X plus 5. Set it equal to 0, and you get x equals -5. You take the -5 and put it into our simplified. So we get y equals 1 over -5 plus 4, which is 1 over, oh my word, what did I do? Go back. No, go back. Stop. Okay, I messed up. Oh, here, there we go. 1 over -1, which is -1. So our whole is -5, -1. Sorry about that. And then our domain has to go with our vertical, x not equal to -4, and our x value of a whole. So there's 2 things that x can't equal. And our range is our horizontal and our y value. So there's 2 values there. And let's see what this is going to look like. I gotta draw that better. All right, I'm going to erase this so I have some more space. Let's draw our asymptotes. X equals -4, 1, 2, 3, 4. Y equals 0. So it looks like this. And we have an x-intercept. There's no x-intercept, but we have a hole at the point -5, -1. 1, 2, 3, 4, 5, -1. So there's a hole right there. So we know it looks like this. And then we know it will look like this. So that is what our graph looks like. So when you are doing these, I need to actually be able to see the holes. Okay, let's look at number 5. I don't know if I want to do number 5. We're going to skip to number 7. Okay, we're going to skip to number 7. And we've got f of x equals x minus 6 over x squared minus 6x. First thing we have to do is simplify. X minus 6. We can take an x out of the bottom and we get x minus 6. And look at that. We can cross that off and it becomes 1 over x. This one will be easy. So our x-intercept, we're going to set the numerator equal to 0. Never happens, so there's none. Our vertical asymptote, we're going to set the denominator equal to 0, so it's x equals 0. Our vertical asymptote, we're going to look at the degree. The degree of the top is 0. The degree of the bottom is 1. That's less, so it is y equals 0. And now the hole. The hole is what we crossed off. So that's going to be x minus 6 equals 0, or x equals 6. There's our x coordinate. We're going to put that in to our simplified, and we get y equals 1 over 6. So our hole is the point 6, 1/6. And our domain is x not equal to 0, x or 6. And our range is y not equal to 0 or 1/6. And let's go ahead and graph this. This is the parent function of the reciprocal, 1 over x, what we did yesterday. So there's our asymptotes. Our hole is at 6. 1, 2, 3, 4, 5, 6, 1, 6. So it's right like that. So it looks something like that and like that. And that is our answer to number 7. All right, let's look at number 8. Number 8 is f of x equals x squared plus 3x minus 28 over x squared plus 12x plus 35. First thing we have to do is simplify this. What multiplies to give you negative 28 and adds to give you 3. 7 and negative 4, what multiplies to give you 35 and adds to give you 12. 7 and 5. So we can go ahead and cross that off. And we're left with x minus 4 over x plus 5. X-intercept, we set the numerator equal to 0. And we get the point 4, 0. Y-intercept. Vertical asymptote, we set the denominator equal to 0, and we get x equals negative 5. Horizontal, we look at the degree. The degree of the numerator is 1, the degree of the denominator is 1, so it's the ratio of the leading coefficients, in this case is 1 over 1, so it's y equals 1. Hole, we're going to take what we crossed off, which was x plus 7, set it equal to 0, and we get x equals negative 7. Then we put that into are simplified, and we get y equals -7 minus 4 over -7 plus 5, which is -11 over -2, which is 5.5. Okay, so our whole is -7, 5.5. I'm gonna have to erase some of that to graph. And our domain is x not equal to -5 or -7. And our range is y not equal to 1 or 5.5. And let's go ahead and graph. I'm going to erase some of that so I have more space. And let's put our asymptotes in. X equals -5, 1, 2, 3, 4, 5. Y equals 1. We got a whole at -7, 5.5. 1, 2, 3, 4, 5, 6, 7, 5.5. 1, 2, 3, 4, 5.5. So it's going to look something like that. So I'm going to make my asymptote more. And let's see if I didn't do my scale very well. So it's going to look something like that. And then down here, we know that it has to be down here because it has to be opposite. Oh, and we also knew that the x-intercept was 4, 0. So I better do that better. 1, 2, 3, 4, 0. So it looks something like that. All right, number 9. This will be the last one that we're going to do here. And we've got f of x equals x squared minus 4x minus 5 over 2x plus 2. First thing we do is simplify. What multiplies to give you -5 and adds to give you -4. -5 and plus 1. And on the bottom, we can factor out a 2. And we get this. We can cross that off, and we get x minus 5 over 2. So our simplified equation is f of x equals x minus 5 over 2. What is that? How about if I write it like this? It's a line. So we can find these things. The x-intercept is setting the numerator equal to 0, which would be x minus 5. And so we're going to get x equals 5. So our x-intercept is 5, 0. And our vertical asymptote is setting the denominator equal to 0. There is none. Our horizontal, there is none. There are no asymptotes when it is a line. Our whole, we will have a whole though, because we crossed something off. We crossed off x plus 1, so x equals -1 is our x value, and y is -1 minus 5 over 2, which is -6 over 2, which is -3. So we have a whole at -1, -3. And our domain is x not equal to -1, and our range is y not equal to -3. So we can go ahead and graph this. It's just a line. A whole at -1, -3, 1, 2, 3. An x-intercept at 5, 0, 1, 2, 3, 4, 5, 0. So it looks something like this. And that is the answer to number